Hello and welcome to day 6. I'm going to get right to it because I'm doing this in the morning before work, and stand up starts in a little over an hour. So I'm going to see if I can get through this in under an hour. And if not, I'll break it up into two parts and do part 2 around 6 o'clock. But let's see how far we can get. Day 6, Lanternfish. The sea floor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely, each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a singular number that represents the number of days until it creates a new lanternfish. Furthermore, you reason, a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. Right. Okay. So basically, to get to reproductive age, it needs 2 days. So suppose you have a lanternfish with an internal timer value of 3. After 1 day, its internal timer would be 2. After another day, its internal timer would be 1. Another day, its internal timer would be 0. After another day, its internal timer would reset to 6, and it would create a new lanternfish with an internal timer of 8. After another day, the first lanternfish would have an internal timer of 5, and the second lanternfish would have an internal timer of 7. A lanternfish that creates a new fish resets its timer to 6. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish, your puzzle input. For example, suppose you were given the following list: 3, 4, 3, 1, 2. This means that the first fish has an internal timer of 3, the second fish an internal timer of 4, and so on until the fifth fish, which has an internal timer of 2. Simulating these fish over several days would proceed as follows. After 1 day, 2, 3, 201, 2 days, 1, 2, 1, 608, and so on and so on. Each day, a 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1 if it was present at the start of the day. In this example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of 5,934. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? Okay. So first step, let's get the puzzle input. And put that in problem input. And we've also got test input, and test input is 3, 4, 3, 1, 2. Okay, so first thought is I imagine it's going to grow exponentially, it says it's going to grow exponentially, so we may run into some performance bottlenecks if we do it the straightforward way, but let's see where those are. So what we can do is I'll create an object and create some tests. And we can figure out where to go. let's see here. So we want a class, we want a what is this called? You can model each fish as a single number that represents the number of days until it creates a new lanternfish. Okay. Ages, this means. Okay, so let's see, what should we name this class? We've got is it lanternfish modeler? What is a let's say it's a lanternfish school. So school of fish, we've got a school of lanternfish, and then we're going to have a method that takes an input of number of days and produces an output given an initial state. Okay, so let's say lanternfish school.rb, and we've got a spec file of lanternfish school lanternfish school spec.rb and class lanternfish school and require rspec, require relative // lanternfish school.rb, describe lanternfish school, and let's just do describe, and we've got an instance method of what should we say, tick, like a clock tick, or a clock tick, and it takes a number of days. So after 1 day, describe after 6 days. I don't necessarily need to do all the days up front, but I think I can do something like this. Let's say test lanternfish school, and make that lanternfish school.new. I guess I'm not using the test input, but 3, 4, 3, 1, 2. It's going to take a string and create a number of fish. And then doing that just to make our tests a little bit cleaner, since we're going to be doing that over and over. Say 1, 2, 3, 4, 5, 6, and then let's do let's do a couple random ones just to make sure. After 17 days a little bit before 13 days, and after 18 days. It's probably way too many. Really, if I have 1, 6, and 13 all correct, I would imagine that the whole thing is correct, but really probably should scope out where there are edge cases. This seems fairly straightforward. So let's say expect lantern test lantern school dot. Actually, method tick seems. Let's say after 1. Seems like a nice API to make sure what's going on. Or really, that seems to make it seem like it's stateless, but I want to actually store state because I want to know how many there are total after the number of days. So let's say instead of after, let's say what's a good word for this? 136 days. Present. So you can model each fish as a single number that represents number of days until it creates a new lanternfish. Let's say days pass, past days. Go forward. And then, right, so we're trying to figure out after 80 days. So let's say go forward. And it's going to take days, so go forward 1 day. And we're going to get the, let's say fish might be the API, to equal, and it's going to be an array of 2, 3, 2, 0, 1. Expect test lantern fish school dot go forward 6 days. Fish to equal 121608. Expect test lanternfish school.go forward 13 days. Fish to equal on 13. I'm going to copy this instead of type it out. And that's closed. Okay, and then expect test lantern fish school go forward 18 days to equal there's a total of 26 fish. Okay. Okay, so that seems like a good start, and we can run the tests. And test lanternfish school is not available on an example group. It is the I don't have a good can't come up with a good body for that it block, but this seems like a good start until something better comes to mind. Cool. Wrong number of arguments given 1, expected 0, so we can do this. School, say school string. And let's see, it's going to change under method go forward days, and they should start failing because fish, adder, reader, fish. I'm going to find method fish for nil class. It's not chaining. It probably doesn't make sense to chain that either. So let's change that over to a better API here. Okay, and then this is back at 6, 13, and 18. Okay, so now we're failing for the right reason. We want at fish to equal school string dot split on comma and map to I. And then we'll do this. Okay, cool. So we've got that first set. So let's see. First thing we want to do is, so we want to add the fish to the end, but we also want to not, so we want to add them to the end afterward. And the way to do that, if we're going to modify this array of fish, we either need to clone or need to only iterate to where we are at the start. Does it make sense to modify it in place or create a new one each time? Probably makes it easier to create a new one each iteration, right? Yeah, I think I'm leaning toward create a new one each iteration, and I have a nice idea for how I might do that. So if I have a private method of increment day, and do this days.times increment day, and increment day is going to have a new school equals array at fish dot each do that sucks, fish and fish, so at fish equals new school. Oh, I need to put it on the end, huh? I'm still gonna have that same trouble. Let's see. I don't necessarily need to get into optimizing it just yet, but one thing that jumps out to me is that I know how many 8s we're going to put at the end when we're done, because we just need to look at how many zeros there are. But let's see how complicated this code gets if we let's say days equal to 0 dot count. Fish equals new school at fish, or number of 8s dot add an 8 to the end. And there's probably a really simple way to think about this, huh? But anyway, let's get these tests passing and see how bad the performance actually is. And how many, we're only going to need to do 80 iterations of 5,394. It's probably going to be pretty bad with the problem input the size it is. So we might have the problem somewhat solved, but be time limited on just like how long it's going to take. But I'm sure there's a faster way to figure this out to solve this problem. But anyway, so we need to do let's say fish days, and if fish days minus equals, or fish days equals fish days minus 1, and then if fish days is less than 0, we set fish days equal to 6. And then we do new school of fish days. And I think that takes care of it. We still have one more, and this is after 6 days. What are we doing wrong here? Why is 6 days off? But all the others are right. Did I do something wrong here? Yeah, 6 days is not 1, 2, 1. 6 days is 4, 5. There we go. I had day 2's solution. Okay, so we've got the test stuff passing. Let's check out the solution. So if we do input equals file dot open, I know there's file dot read, but I don't remember exactly how to, if there's anything special I need to do. So this works just fine. Problem input dot read. And then we have require relative lanternfish school.rb, and then we've got school equals lanternfish school new input. We've got school.go forward 80 days, and then we need to do school.fish.count. Number of fish after 80 days is school.fish.count. And let's see how bad the performance is. Yeah, not bad. 379,414. 379,414. Hey, right answer. That was quick. Did that in 23 minutes. That means I'm nervous about part 2 now. Okay, part 2. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example above, there would be a total of a big number. How many lanternfish would there be after 256 days? So, let's test that out. Let's see how word 256 puts number of fish after 256 days. We might be waiting a little while. I guess I should. Well, while this is running, I can think of maybe some ways to optimize this. What's a relationship we've got here? So we know the 8s are getting added, and we know that after let's see, it starts at 5, 6, 7, 9, 10, 10, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. So that's interesting. So it looks like it grows by 1, grows by 2, grows by 1, grows by 1, grows by 3, grows by 2, grows by 2, by 0, goes by 1, 1, 4. So it's 0, 1, 1, 2, 0, 0, 0, 0, 1. There's another approach to this. Do we need to So each fish is responsible for a certain number of fish after a certain number of days. There's at least, well, I guess my question is, do I need to iterate over every single fish each day? I feel like that's the first question. Is there a way to figure out a way to not iterate and to maybe group them into numbers of days? And so I can move arrays around. So if I know how many are in day 1, day 2, day 3, day 8, I can shift them around. And then each iteration, I'm only moving certain arrays around. And let's see, any of these are basically going to follow each other. So 6, 6, 6, 6. Yeah, maybe each of those groups can go a different way here. Well, I've got the tests. I've got this running, so I might as well try something else here while that's going. So instead of iterating through each of those, I can iterate through each number each time and move the groups. That's probably a much faster way, but I probably should have output the number of days. So I could see where we are and how important it is to finish this optimization versus just letting this go. Let's make a go forward 2 method. And actually, let's leave that and copy solution 2. And solution 2 is going to be go forward 2. And comment out a 256 days. Let's also copy this so we can test that we're still correct here. Okay, so %s go forward 2. Cool. Okay, and so we want go forward 2 days to call days.times increment day 2. And let's do that. It's going to operate on fish2. But fish2 and solution 2 fish2.count. Let's do it here too, just so that when I comment that, uncomment that, it is a little bit simpler. Okay, so from here we can do let's change the test. Are those tests changed? Yeah. Okay, so now it's just a matter of fish2, well, let's say school string dot split on comma map 2i, or actually I can change the fish here. So what we have now is fish2 equals a hash of 0, 1, 2, 3, 4, 5, 6, 7, and 8. If I were doing this for production code, I would probably figure out a way to do this a little bit differently, but and actually I don't even need to know, all I need to know is how many there are in each group. Right? Yeah. So I actually don't even need to iterate on them. I just need to know how many are in the number. And it's actually at fish dot count of 0, fish dot count of 1, fish dot count 2, 3, fish dot count 4, fish dot count 5, fish dot count of 6, count of 7. Nope, I missed a number. How do I count? 2, 3, 4, 5, 6. And at fish.count of 8. Okay, so I'm pretty sure that's how that works. A equals 1, 1, 2, 3, 4, 5, 10, 10, 24, 23. Okay, A dot count 1. A dot count 2 should be 1. Yeah, okay. So now increment day 2 is going to look a lot like this, only only a little different. Increment day 2, and so new school equals it's going to be a blank hash of that same format, but they're all going to be empty. So those are all going to be zeros. And then we can start off with new school sub 8. Is equal to, so it's the number of zeros, right? So it's at fish2, and then at the end it's going to be fish2 equals new school. And so this is at fish2 sub 0. Can I do that? Can I have numbers as keys and hashes? I think I can. For whatever. A sub 0. Yeah, okay. And that's still running. I wonder if I'm going to start hearing my fans soon. Okay, so new school of 8 is going to be the number of fish at 0. The number of fish at new school of 0 is going to be the number of fish at 1. The number of new school sub 1 equals at fish 2 sub 2. New school, so it's going to get weird at 6 because 0 starts over at 6 and 7, so I'm going to need to add the 2 together. So new school 2 at fish 2 sub 3. New school sub 3 equals at fish 2 sub 4. New school sub 4 equals at fish 2 sub 5. A new school 5 at fish 2 sub 6. New school 6 equals at fish 2 sub 0, so add the zeros, plus at fish 2 sub 7. And then new school of 7 equals at fish 2 sub 8. So the ones that were on 8 last time. And it's not just fish2.count, and it's really fish2. Let's change the test here. Oh, well, actually I need to change the number here. So I need to change the assertion since we're not actually storing that, and I don't want to go through creating that list again. Fish2 dot values dot count, or values dot sum to equal, and after 1 day, it's 1, 2, 3, 4, 5. Fish2.values.sum to equal, or values.sum on day 6 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probably don't need this. Yeah, but we know that 18, there's 26. So that should still work. Let's do still running. Okay, day 6. R spec, lanternfish, school spec 2. Cool, they all still pass. So now if I do solution 2, we should still get the same fish2.values.sum and values.sum. $379,414. So same solution for day 80, or for 80 days. And then 256 days is that, and it's still running. Pretty confident this is going to be the answer, but famous last words, right? Not right answer, your answer's too high. If you're stuck, make sure you're using full input data. General tips. Okay, what did I get wrong here? Why did I get the day 1's solution right and the day 2's wrong? Suppose the lanternfish live forever and have unlimited food and space. When they take, after 256 days in the example above, there would be a total of, well, let's add that test and see where we're at. Okay, so after 256 days test, 256, we expect the total of, this is what I should have done originally, it still passes. Did I screw something up in this? School.go forward. Oh. Yeah, I don't want to go forward 80 days, and that's probably another thing that's because it's not just 256 days, it's 80 plus 256 days. Solution 2.rb. So that's significantly smaller, and I bet that would have passed, huh? There we go. Right answer. And that's probably not even worth running this because it's dead. Okay. Yeah, interrupt. Cool. Got the 2 stars in well under an hour. I guess you needed to find that that optimization there of not actually needing to model the fish. But it actually brings up a one good problem-solving technique that I learned. I've actually given this as advice to people that are interviewing for software jobs. Is anytime somebody asks you to optimize a problem in an interview, if they ask you, can you do this in can you do this faster? Can you do this in linear time? Or can you do this in constant time? Whatever. Well, not constant time. Usually what they're asking, one of the ways that I use to solve that problem is how can I do this with a hash? I did that today. As I was sitting there thinking of how can I solve this problem? I was thinking, could I put these numbers in a hash some way? And that's where the idea of putting them in an array came from. Then once I started that, realized that didn't even need the array, could just do the count. So if you watched, thanks for watching. Otherwise, I will see you tomorrow.